When both the main breaker and the air conditioning breaker trip simultaneously, several potential causes should be considered. These include overload, short circuit, loose connections, ground fault, and a damaged breaker. Overload refers to excessive current draw, typically caused by a malfunctioning or high-demand appliance or device, such as the air conditioning unit itself. A short circuit is a fault in the electrical wiring or equipment that causes a sudden surge of current, resulting in an immediate breaker trip. Loose terminals or connections can create high resistance and overheating, ultimately leading to breaker tripping. A ground fault presents a path for current to flow through the ground wire instead of the intended circuit, potentially causing a breaker trip. Finally, a faulty or worn-out breaker may not trip properly or may trip prematurely. To troubleshoot this issue, consider the following steps. Firstly, check for an overloaded circuit. Unplug or turn off all non-essential appliances and devices connected to the circuit associated with the trip breakers. Reset the breakers and observe if they hold. If they do hold, gradually add loads until the breaker trips again. This process helps identify the potential culprit appliance or device. Secondly, inspect the air conditioning unit. Ensure that the air conditioning unit is clean and free of debris. Check the electrical connections, wiring, and any visible components for any signs of damage or loose connections. Thirdly, check for a short circuit. Utilize a voltage tester to check for continuity between the neutral and ground wires in the panel. If there is continuity, it indicates a potential short circuit. Fourthly, tighten connections. Inspect and tighten all electrical connections in the panel, including those of the main breaker and the air conditioning breaker. Fifthly, consider breaker replacement. If all other troubleshooting steps fail to resolve the issue, it's possible that either the main breaker or the air conditioning breaker is damaged. Contact a qualified electrician to replace the faulty breaker. Always adhere to safety precautions when working with electrical components. Always turn off the main breaker before working on any electrical components. Use proper safety gear, including insulated gloves, safety glasses, and protective clothing. If you are not comfortable troubleshooting electrical issues, it's strongly recommended to contact a licensed electrician for assistance. Now let's delve into each of these potential causes with a bit more depth. Overload conditions occur when the total current demand on a circuit exceeds the rated capacity of the breaker. This can happen if too many appliances are running simultaneously on the same circuit, or if a single appliance, like an air conditioner, is drawing excessive current due to a malfunction. In the case of the air conditioner, a clogged air filter, a failing compressor, or a refrigerant leak can all contribute to increased current draw. A short circuit, on the other hand, is a more direct and immediate problem. It happens when there is an unintended low resistance path for current to flow, bypassing the normal circuit components. This can be caused by damaged insulation, loose wires touching each other, or a foreign object creating a conductive bridge. The sudden surge of current in a short circuit trips the breaker almost instantaneously as a safety measure. Loose connections can be sneaky culprits. Over time, the terminals and connections in an electrical panel can loosen due to vibration, temperature changes, or corrosion. A loose connection creates increased resistance, which generates heat. This heat can eventually damage the breaker or the wiring, leading to a trip. In some cases, the heat can even pose a fire hazard. A ground fault is similar to a short circuit, but instead of the current flowing back to the neutral wire, it flows to the ground wire or a grounded object. This can happen if the insulation on a wire is damaged and comes into contact with a metal enclosure or a grounded surface. Ground faults are particularly dangerous because they can create a shock hazard. Ground fault circuit interrupters, or GFCIs, are designed to detect these faults and trip the circuit very quickly, preventing electric shock. Finally, a damaged breaker can be the cause of seemingly random tripping. Breakers are mechanical devices that can wear out over time. The internal components can become corroded, the spring mechanisms can weaken, or the contacts can become damaged. A faulty breaker may trip at a lower current than it's rated for, or it may not trip at all when it should. Now let's elaborate on the troubleshooting steps. When checking for an overloaded circuit, it's not enough to just unplug a few small appliances. You need to consider the power consumption of all devices connected to the circuit, including lights, electronics, and even small appliances that you might not think of as hydro. Look for the wattage rating on each device and add them up. If the total wattage exceeds the capacity of the circuit, you've likely found a problem. When inspecting the air conditioning unit, pay close attention to the electrical connections at the unit itself, as well as the wiring that runs from the panel to the unit. Look for any signs of damage, such as frayed wires, cracked insulation, or corroded terminals. Also, check the capacitor, which is a common point of failure in air conditioning units. A bulging or leaking capacitor is a sign that it needs to be replaced. When checking for a short circuit with a voltage tester, you're essentially looking for a path of low resistance between the neutral and ground wires. A properly functioning circuit should have very high resistance between these 2 points. If you find low resistance, it indicates that current is flowing where it shouldn't be. It's important to note that this test should be performed with the breaker turned off for safety. When tightening connections, be careful not to over-tighten them. Over-tightening can damage the terminals or the wires. Use a properly sized screwdriver and apply firm, even pressure. Also, make sure that the wires are properly seated in the terminals before tightening the screws. When replacing a breaker, it's crucial to use a breaker of the same type and rating as the original. Using the wrong breaker can create a safety hazard. Also, be sure to turn off the main breaker before removing the old breaker and installing the new one. Consider these additional points. Understanding your electrical panel is key. Familiarize yourself with the location of the main breaker and the individual circuit breakers. Label each breaker clearly so you know what circuits they control. Regularly inspect your electrical panel for any signs of damage, such as rust, corrosion, or loose wires. If you notice anything unusual, contact a qualified electrician. Consider investing in a circuit analyzer. A circuit analyzer is a tool that can help you diagnose electrical problems more accurately. It can measure voltage, current, resistance, and other parameters, giving you a more complete picture of what's going on in your electrical system. Consider the age of your electrical system. If your home is older, your electrical system may be outdated and unable to handle the demands of modern appliances. Upgrading your electrical panel and wiring may be necessary to ensure safety and prevent problems. Be aware of the signs of electrical problems. Flickering lights, sparking outlets, and burning smells are all signs that something is wrong with your electrical system. If you notice any of these signs, contact a qualified electrician immediately. Remember, electricity can be dangerous. Always take safety precautions when working with electrical components. If you are not comfortable troubleshooting electrical issues, it's always best to contact a licensed electrician for assistance. In addition to the above-mentioned troubleshooting steps, consider these points about the air conditioning unit itself. A dirty air filter can restrict airflow, causing the unit to work harder and draw more current. Regularly clean or replace your air filter to ensure proper airflow. The condenser coils, which are located on the outside unit, can also become dirty and restrict airflow. Clean the condenser coils regularly with a garden hose or a coil cleaner. A refrigerant leak can cause the air conditioning unit to lose its cooling capacity and draw more current. If you suspect a refrigerant leak, contact a qualified HVAC technician to repair the leak and recharge the refrigerant. The compressor is the heart of the air conditioning unit. If the compressor is failing, it can draw excessive current and cause the breaker to trip. A failing compressor may make unusual noises or fail to start. Contact a qualified HVAC technician to diagnose and repair or replace the compressor. The fan motor in the air conditioning unit can also fail, causing the unit to overheat and draw more current. A failing fan motor may make unusual noises or fail to spin properly. Contact a qualified HVAC technician to diagnose and repair or replace the fan motor. Furthermore, consider the impact of weather conditions. During periods of extreme heat, air conditioning units have to work harder to maintain a comfortable temperature. This increased workload can put a strain on the electrical system and increase the likelihood of breaker tripping. To mitigate this, consider raising the thermostat temperature slightly during peak hours to reduce the load in the air conditioning unit. Also, ensure that your home is properly insulated to minimize heat gain and reduce the workload in the air conditioning unit. Proper insulation in the walls, ceilings, and floors can significantly reduce energy consumption and improve comfort. Seal any air leaks around windows, doors, and other openings to prevent drafts and heat loss. Consider using energy-efficient window coverings, such as blinds, shades, or curtains, to block sunlight and reduce heat gain. Landscaping can also help to reduce heat gain. Planting trees and shrubs around your home can provide shade and reduce the amount of sunlight that reaches the building. Finally, remember that electrical codes and regulations vary depending on your location. Consult with a qualified electrician to ensure that your electrical system is in compliance with all applicable codes and regulations. This includes ensuring that your electrical panel is properly sized for the load and that all wiring is installed correctly. Regular electrical inspections can help to identify potential problems before they become serious safety hazards. A qualified electrician can inspect your electrical system and identify any issues that need to be addressed. In summary, troubleshooting simultaneous main and air conditioning breaker tripping requires a systematic approach. Start by identifying the potential causes, such as overload, short circuit, loose connections, ground fault, and damaged breaker. Then follow the troubleshooting steps to isolate the problem. Remember to always prioritize safety and contact a qualified electrician if you are not comfortable working with electrical components. By following these guidelines, you can effectively diagnose and resolve breaker tripping issues and ensure the safety of your electrical system.